Okay, we are right at the beginning of a massive, and I mean massive, revolution in software. It's completely redefining what it even means to be a developer. It's not really about writing code anymore. It's more like conducting an orchestra of AI agents. So let's dive into this unseen revolution that's happening right under our noses.
It all kicks off with something that honestly feels like pure magic. You see a developer type a prompt, just a simple natural language description of what they want, and boom, almost instantly a working application just appears. The whole thing seems super smooth, incredibly efficient, and, completely under human control. But what's actually happening underneath the surface? That's a whole other story.
This new way of working actually has a name: vibe coding. It was coined by the brilliant computer scientist Andrej Karpathy. And it's all about shifting your focus away from writing code line by line and instead just expressing your intent. The developer's job becomes more like a director, just articulating the vibe of a feature, while the AI does the heavy lifting of translating that vibe into actual functional code. Now, to be clear, this is way beyond just AI suggesting the next line of code for you. We are making a huge leap from AI as a helpful assistant to AI as an autonomous builder. The developer describes the intent, and the AI literally constructs the entire feature. And here's the wild part. Sometimes a human might not even review a single line of the code that gets created. And this is where the story takes a pretty serious turn. The convenience of vibe coding, that's just the warm-up act. The real disruption, the thing that changes everything, begins when these AI agents go from just generating code to generating, other agents. They start creating systems that build and optimize themselves completely without human visibility. And that brings us right to the heart of the problem we're going to unpack today, what's called the recursive explosion. This is what happens when the autonomy of these systems starts to grow exponentially, way, way faster than any human can possibly track or understand. So how does this even work? Well, picture this. To tackle a really complex problem, a parent AI agent can just dynamically spawn a whole team of specialized subagents. It creates what some researchers call a subordinate society, just to solve one specific problem. And then, once the task is done, the whole society just dissolves. It's an incredible, almost biological way to scale intelligence. And look, if you think this is all just theory, you have to see this number: 144 to 1. For every single human user in a typical organization, there are about 144 non-human identities. We're talking about things like API keys and service accounts that allow all these agents to operate on our systems. It's a gigantic, invisible workforce, and it creates a massive new surface area for things to go wrong. So with this huge, interconnected system of agents, we get a totally new kind of risk: the cascading failure. See, unlike a regular bug that might just crash one service, a failure in one of these agentic systems, it doesn't stay contained. It's like a virus. A single bad piece of information can spread, infecting other agents and compounding until you have a system-wide catastrophe. Let's walk through how this can happen step by step. It could start with just one tiny piece of corrupted data. That bad data leads to a flawed plan, which then causes a wrong action. But here's the kicker. Because all the other agents in the system are built to trust each other for efficiency, they just accept that action without checking it. The entire system-wide failure can be complete in milliseconds, way faster than any human could ever notice, let alone do anything about it. And what's really crucial to understand is that these errors don't just spread, they amplify. You get these feedback loops where small errors snowball and grow exponentially. You get trust transitivity, which basically means if one agent trusts a bad source, the entire chain of trust is broken. And maybe the most dangerous part, you can get these harmful emergent behaviors, where a bunch of agents, all trying to do the right thing and optimize their own little tasks, end up creating a disastrous global outcome that nobody ever intended. This quote, it really cuts right to the heart of the governance problem. Even though we're delegating all these tasks to autonomous agents, we, the humans who built the system, are still on the hook. We're still accountable. So the big question is, who's responsible when it all goes wrong? And that's the accountability crisis in a nutshell. The decision-making process is so complex, so opaque, that trying to find the root cause of a failure becomes almost impossible. This creates what are called responsibility gaps, where human supervisors get blamed for failures they literally could not have prevented. The system is just too fast and too distributed for our old ways of thinking about oversight. So we really have to ask ourselves,
is this new world of vibe coding and autonomous agents a true revolution in productivity? Or have we just opened a Pandora's box of risks that we can't even see yet, let alone control? But here's the good news. There is a path forward. The solution isn't to hit the brakes on progress, but to fundamentally rethink our own role in all of this. It means we have to shift from being the implementers, the people who write the code, to being the governors, the people who design the rules of the entire system. The best way to understand this shift is to compare two models. The old way is human in loop, where a person has to manually approve every critical step. It's safe, sure, but it's incredibly slow. It's a bottleneck. The new model is human on the loop. In this world, the AI operates autonomously at machine speed, while the human acts as a supervisor, monitoring from above and only stepping in when there's an exception. It's the perfect balance of autonomy and oversight. So the first pillar of this solution is all about boundaries and containment. We need to build what are basically sandboxes, completely secure, isolated environments where agents can do their thing without ever being able to touch our critical systems. You combine that with automated circuit breakers, just like the ones in your house, that are designed to spot trouble and halt a cascade before it can spread. The second pillar is intervention. This means we build in mandatory checkpoints for high-risk decisions. Think large financial transactions or deploying code to production. We have to make sure there's a big, red, frictionless pause button a human can hit at any time. And we need automated systems that act like a firewall for behavior, automatically freezing an agent if it starts to drift away from its original mission. And the third pillar, which is absolutely crucial, is auditability. We need to log every single action an agent takes in an immutable, tamper-proof record. Using things like cryptographic event chains, we can link each event to the one that came before it, creating a verifiable history that no one can mess with. This gives us the power to do forensic reconstruction, so we can always figure out not just what happened, but why it happened. And for anyone out there thinking, wow, that level of security must slow everything down to a crawl, well, this slide proves that's just not true. The data shows that creating a cryptographically secure verifiable log for a single agent action takes on average just 0.08 milliseconds. That's fast enough to log over 12,000 events every second on a single thread. Robust security isn't a performance bottleneck. It's a high-speed engineering reality. All right, let's bring this all home. What's the big takeaway from all of this? Well, it's a profound shift in our role as developers and in the skills we need to succeed in this new agentic era. Here's the most important point to remember. Your value is no longer about your ability to write code faster or better than an AI. The future is not about competing with agents on implementation. It is about having the wisdom, the foresight, and the engineering skill to design the guardrails that govern them. So what does that mean for you, practically? Your most valuable skills are changing. They are now about designing strict constraints and secure sandboxes. They're about engineering systems that guarantee accountability and traceability. Ultimately, your most important skill is mastering the art of maintaining meaningful human control over systems that are designed from the ground up to operate far beyond human speed. And this line just perfectly illustrates the new philosophy we all have to adopt. We can't expect every single AI agent to be perfectly safe on its own. It's an impossible task. Instead, safety has to be an inherent property of the system's architecture. It needs to be built into the very foundation, making it the default state, not some optional add-on. Which leaves us with one final, an absolutely critical question. As these systems become more and more autonomous, capable of writing, deploying, and optimizing themselves in a continuous loop, who writes the rules? The answer is, we do. And that is both the great challenge and the incredible opportunity for the next generation of software engineering.